This is a quick recap of the chain rule, which is here on the maths tables, and you use the chain rule to differentiate a function which is made up of one function inside of another function. Let's say we have a function y equals f of x, and we can break that function up into u of v of x. So for example, let's say y equals sine of 2x. In this case, our outer function u is going to be sine, and it's going to be sine of v. So u is going to be sine of v, and v is going to be the piece inside the brackets, which is 2x. So we let u equals sine of v, and we let v equal to 2x. Now, the chain rule tells us that dy dx is equal to du dv, the derivative of u with respect to v, times dv dx, the derivative of v with respect to x. So, du dv is going to be cosine of v. The derivative of sine is cosine, and we differentiate with respect to v, so with respect to what's inside those brackets. The derivative of v with respect to x is just 2. So our answer is going to be du dv, which is cosine of v, times dv dx, which is 2. And then we substitute in what we know v is, which is just 2x. And we put the 2 in front, and there's our answer. dy dx is equal to 2 times cosine of 2x. Second example. Let's say f of x is equal to x squared plus 5x to the power of 10. We could multiply that out. Write down x squared plus 5x multiplied out 10 times. Do that calculation and then differentiate it. But that would take all day. So instead we're going to use the chain rule. So we'll write it down. F of x equals x squared plus 5x to the power of 10. Now I've put the colour on here to show which is going to be our inner function and which is the outer function. So u is kind of the outer function. It just takes v to the power of 10. And then the thing inside the brackets, v, is x squared plus 5x. So first we'll differentiate u with respect to v. So the derivative of v to the power of 10 with respect to v is 10v to the power of 9. The same as if you differentiated x to the power of 10 with respect to x, it would be 10x to the power of 9. Then we differentiate v with respect to x, and we get 2x plus 5. It's fairly straightforward. Then we apply the chain rule. We say that the derivative of f of x, f prime of x, is equal to du dv times dv dx. So du dv is 10v to the power of 9. So I'm just going to put in v here and say it's x squared plus 5x. And then we multiply on dv dx, which is 2x plus 5. And then I'm multiplying the 10 times 2x plus 5 here at the front, and I'm getting 20x plus 50 times x squared plus 5x to the power of 9. And that is the answer. Most of the time you can do the chain rule in one line, in one step. Just remember that you will have an outer function u and a function inside that v, and you will differentiate the outer function with respect to whatever's in the brackets, and then multiply that whole thing by the derivative of what's in the brackets. So here the outer function u is sine, and what's inside that sine function is x squared. To calculate the derivative, dy dx, the derivative of sine is cosine, and inside that bracket is still going to be x squared, what we called v. The derivative of x squared is just 2x, so we multiply the whole thing by 2x. And that's our answer. If y is equal to sine of x squared, then dy dx is equal to 2x times cos of x squared. Next example, y is equal to cosine of 1 over x. The outer function here, u, is cosine. The inner function v is 1 over x, which we will write as x to the power of minus 1. Now we calculate dy dx with the chain rule. The derivative of cosine is minus sine. So it's going to be minus sine of, what's in the brackets doesn't change here, x to the power of minus 1. Then I multiply the whole thing by the derivative of what's inside the brackets, what we called dv dx before. The derivative of x to the power of minus 1 with respect to x is minus 1 times x to the power of minus 2. And I multiply by that in front. Minus 1 times a minus sign cancels the minuses, we get positive. X to the power of minus 2 is equal to 1 over x squared, and x to the power of minus 1 is equal to 1 over x. We can arrange that, if we like, to give our final answer of dy dx is equal to sine of 1 over x squared. The last example is y equals sine squared of x. Now this means sine of x and then squared. So we could do the product rule like this. Or we could use the chain rule by taking our outer function u as just being squared, v squared, and the inner function here is going to be sine of x. So that's the outer function, or u of v. And then inside those brackets we'll put our v of x, which is going to be sine x. To calculate dy dx, I differentiate the outer function in blue, which would be u of v, with respect to what's in the brackets, which would be v. So I multiply by the power, which is 2, and then reduce the power by 1. What's inside that bracket hasn't changed, so it will still be sine of x, which is our v in this case. Finally, we multiply in front by the derivative of what's in the brackets, the derivative of that red part. The derivative of sine x is cosine of x, so we multiply in front by cosine of x. Then we tidy all that up to give our final answer, which is dy dx is equal to twice sine x times cosine x, the same answer we got from the product rule.